All right, good morning, I guess Leonard in this case. We're here today to talk about the surveying toolkit for Map 3D. It's been recently released. Um, this toolkit provides additional functionality to Map 3D, and it is available via download. It's a free download from the Autodesk website, and it's available for all subscription customers. So if you're on subscription, this tool is available to you. First, we'll take a quick look at Map 3D. Map 3D, again, I think everybody's familiar with Map 3D. It is a leading engineering platform. It's very good at creating design data. It's also now very good at managing spatial data. The spatial data comes in many GIS formats, whether it's Esri shape or SDF. Maybe it's a database that you're connecting to. Map is very good at managing this data now using the FDO tools, and we'll talk about those in the presentation. Some of the new features in Map 3D, faster, better, smoother. They've done quite a bit to enhance the functionality and the speed with which Map can work with large data sets. There's been some user interface enhancements. Citrix ready. Map and as well as the other Autodesk products are now Citrix ready, so you can use the Citrix option for deploying applications these days. There's a set of industry toolkits for water, wastewater, and electric that are available also for free download on the Autodesk website. And then the surveying tools that we're going to talk about today. So what do the surveying tools bring to Map 3D? They bring an improvement in point data support. Typically, when working with point data, it's been fairly cumbersome in Map 3D to get that point data into your drawing, whether that point data is in an ASCII comma delimited format or a database of some sort. The surveying tools improve that capability. You also now in Map 3D have the ability to create surfaces. Those can be tin surfaces, or they can also be raster surfaces like a geotip. And this type of surface you get is based on the type of data you're creating that surface from. We'll talk about surface creation at length in the hands-on. There's a couple additional Kogo commands that are added to the input and inquiry toolbar. We'll talk about those as well. Is support for land XML, which is new in Map 3D. You can now share surfaces back and forth with not only other vendors like MicroStation, but also other applications like Civil 3D. You can share those land XML surfaces very easily back and forth now with Map 3D. There's an API for the survey tools so that you can customize based on top of those. And there's also some good documentation. So improved data support, point data support. So now you can work with ASCII files. You can connect via FDO to data sources, and FDO stands for Feature Data Objects. And you can also use AutoCAD points now to build surfaces and then share those surfaces with other design applications through land XML. Map 3D is also very good at working with very large data sets. Points and contours can also be created, or can also be taken, and surfaces created from those. Those of you familiar with shapefiles, a lot of contour data exists out there in shapefiles, but that contour data is sometimes hard to wrap your mind around and get a 3D surface from. Map 3D now makes it very easy to do that. Map 3D survey tools also bring a couple of new Kogo commands. So when you're trying to locate points for endpoints of lines or insertion of blocks, there are a couple new commands allowing you to specify a point based on bearing and bearing and where those two bearings intersect, or a distance and distance from 2 points and where those two distances intersect. And we'll see those in the hands-on here in just a moment. You can also now import and export tin surfaces to LandXML. We talked about that a little bit already. And again, that gives you the ability to share surface data with other applications such as Civil 3D and also other vendors such as MicroStation that support the LandXML exchange format. You can also export grid-based surfaces to a GeoTIFF for use in other applications. There's a very good documentation set that comes with this survey tool. It's available under the Help menu. So, quickly, the benefits. Easily create and visualize and analyze 3D surfaces. We'll see that today in the hands-on, how we can do some slope and hill shading analysis based on raster or tin surfaces. We can update drawings and maps to reflect the as-found locations in the field by importing point data. And we can draft accurate information based on those two new Kogo input commands, the bearing command and the distance command. So let's get to some hands-on here. Go. So this is Map 3D. Let me just go ahead and open a drawing to start with here. So let's start by talking about the two new Kogo input commands that allow you to specify a point based on either a bearing in bearing or a distance in distance. So let me zoom up on a portion of this drawing here. So we've got a couple of houses here, and we want to locate a street light at the corner here, and the data collected in the field gives us the intersection point of two distances from the corners of these houses. Now, you can do some manual calculation on your calculator and piece of paper and come out with an XY location here, but it would be much easier if you could just enter this data as it was collected in the field. So let me go ahead and start the insert command. I'm going to insert a block. We have a street light block. I want to specify its insertion point on the screen, and I also want to specify rotation on the screen. So now that I am prompted for a point to locate this block, I can go ahead and use one of the commands, one of the Kogo input commands. They are transparent, so I can start them in the middle of another command. So let's use the distance. So if I hover over this new button, it tells me that's the distance command, so I'll go ahead and start that. I'm now prompted for a first point, so let's go here. From this point, I know the distance collected in the field was 32.4, and from the corner of this house, the distance collected in the field was 41.1. So it jumps me into that location. It says, okay, those two distances intersect at 2 points. So which of these 2 points do you want to locate this street light at? Well, point 1 makes more sense, closer to the street. So there is my street light, and now I can set its rotation about like that. So that is how the distance command works to locate points. How about the bearing command? So let me find my other location here. There we go. Had it marked. There we go. So again, we want to locate a street light on this corner, but what we have is we've got the bearing of two lines, one from the corner of the house and one from the corner of this intersection, and the location where those bearings cross is where we want to locate a street light. So again, starting the command to insert a street light. Again, I'm prompted for the typical select a point to insert this block. I can go ahead and start the bearing command transparently. It prompts me either for a line, so if I've already got a line drawn in here, it can get the bearing from that line, but what I've got is a point. So first I'll specify a point, and let's start with this corner intersection here. It needs to know what quadrant I'm drawing in for a bearing, and in this case I'm drawing in quadrant 4. And now it needs to know the bearing, and the bearing that was collected in the field is 7 degrees. So I'll just input that. It now needs the input of a second line or point, so I can go with point. And the starting point here. What quadrant am I drawing in? In this case, I'm drawing in quadrant 1 with a bearing of 43. So this is the point where those two bearings intersect. You can now specify the rotation, be something like that. So that's how the two new Kogo input commands work, either distance distance or bearing bearing. And I will open this up for questions at the end of this, so please save your questions till the end of the presentation, and then we can have a discussion about some of these tools. So the next thing we want to talk about is the ability to bring field collected data collected in an XYZ format, into Map3D using these survey tools. So let me open yet another drawing here. So in this case, we have some survey information that was collected in the field that specifies manhole locations in this drawing. So we can easily import that data collected in an ASCII format by using our new button. This is a new tool here. It's called 3D Surface, but it does much more than just 3D surfaces. It also allows you to bring in points from other sources. So let's go ahead and start that command. This is the new dialog box. And the first thing we need to do is connect to a source of data. So we've got several options here for sources of data. We've got external files. We've got a connection, which is an FDO connection through our task pane, points in the drawing. In this case, we've got an external file that we want to get some information from, and that file exists in a CSV format. So here's our sewer manhole. This might have been data collected in the field. In this case, it's in a CSV format. So we'll open that up. We see the northings, the eastings, no elevations on these points. These are just 2D points. So let's go ahead and import these points into the drawing. So there those points now exist by importing them into the drawing. And they've got a block on them. We have a different block in our drawing that we would like to use, and that block we would like to use is sewer manhole. So using the express tools in this case, under our block, I can replace a particular block with another block in all instances of that in the drawing. So I'll go ahead and do that. So I'll select the block to be replaced, and I can pick it in the drawing. So this is the block I want to be replaced. It's called the map survey point. What block do you want to replace it with? In this case, let's use the sewer manhole. So there we go. We've now replaced one block with another, so we've got them on the sewer manhole. Let's make sure they're on the correct layer. Jump into the properties really quick. We see that they're on the layer called points, so that's not what we want. So I'm just going to use my quick select tool. Looking in the entire drawing, I want block references, named sewer manhole, add those to a selection set, and let's put those onto the correct layer. Let's put them onto the sewer layer. So that's one way that the new map surveying tools can help you bring data into a drawing from an external format, in this case points. So continuing on here, in this next hands-on, let's go ahead and take a shapefile that's got contours in it, and let's bring that shapefile into a drawing and take those contours and create a surface from it. Those of you that have done this process in the past know that it can be quite cumbersome. Several steps to get contours to actually have elevation on them. Those of you familiar with shapefile know that contours in a shapefile are 2D entities, and when you import those into AutoCAD or AutoCAD map, they remain at 2D elevation, 0 elevation. So you need to go through a fairly lengthy process of altering those properties to get those contours at a true 3D elevation. Now with the map survey tools, that's all done for you. So let me just go ahead and open a brand new blank drawing here. And the first thing I want to do is I want to add an FDO connection, a feature data object connection, to the shapefile I want to work with. So looking here for a shapefile. Browse out to that. Wrong folder. There we go. So I've got a shapefile here, P-5 contours. Let's open that up. Let's add these to the map, see what we've got here. So here it is, a bunch of contours from a shapefile, and you can see there's quite a few contours. It looks like a lot of elevational relief over here. Pretty flat area over on the right side. We've got some images that correspond to this area as well, so let's grab some of that image information. So I'll connect to a folder in this case called SID images. It's got 4 Mr. SID images in it, so I'll just grab all those. But I don't want those 4 images to behave independently. I want to combine them onto one layer of data. Let's call it SID image. And let's add those to the map as well. So we see how our SID image sits over our contours. Manipulate the draw order here so that the image is below the contours. So we've got the data that we need in this drawing. We've got a pretty nice high resolution SID image. We've got contours. We can now create a surface from this information. Let me turn off my image for a moment here. Let's go ahead and build a surface from this. So using our 3D surface tool, we first specify a source of data, and in this case we've got an FDO connection to data that we can build a surface from. It's in the P5 contours shapefile. You'll notice that the Z elevation is set to 0, but we can have it look into the actual DVF file that accompanies that shapefile and get the elevations for each of these contours from there. So now you see I have true 3D information. Let's see. I think that's all I want to do. I do need to give the surface a name here. Let's call it let's call it shape surface, and the display manager layer we'll call surface. So we'll say OK to this, let it crank away, and it's actually going to build a new surface, a tin surface model from this shapefile information. It does take just a second here. We've got quite a bit of information in this. So we'll let that crank away. So the surface has been created, so that connection should show up for us. Here it is, surface 1 is what I called it. Quickly, easily add that to the map. And there we see a raster-based surface built from the shapefiles. Let me toggle off my contour information for a moment. Still in the draw order, I do want my surface to display at the bottom of the draw order here. So let's jump into 3D and see what we've got here. So we've got a pretty good look at, pan, put this down. So here's a pretty good look at that surface in 3D. Pretty nice visualization. And we can stylize this to make it even a little bit easier to tell what's going on. So I can build a theme on this, and that's theme based on height. We'll go with 5 rules, and we can use a palette. In this case, let's use USGS national palette. So there's a stylization of that surface based on elevations, looking pretty nice. What we can also do is we can drape other layers of information over this 3D surface. So if I toggle my image back on and let it crank away for a moment, you see now that that image has been draped over the top of that surface, and I can do the same thing with the contour layer. So there are the contours draped, although they're spaced a little bit closely to really see what's going on here. Even if I zoom up, it's still a little bit muddled. Turn those back off, but you can easily spin your surface around here and get different looks. So, pretty cool. Let's jump back to 2D here. Toggle that surface back off. Oh, I'm sorry, the image back off. So that's the ability of the Survey Toolkit to create a surface from an external file. In this case, it was shapefiles. How about we create a surface now using points? So we've got some LiDAR information out there in a typical XYZ format. Lots and lots of points typically with LiDAR. In this case, I think we've got a file that's got over 500,000 points. So let's see how we can use that to build a surface from LiDAR information. So let me start with a new drawing. And if you remember, when we created a surface from the shapefile, we first needed to add a connection to that data. Well, LiDAR typically comes to us in some kind of ASCII format, so that's what we'll be looking for in this case. So in this brand new, this blank drawing, I can use my 3D surface command, and the source of data in this case is going to be an external file. I'm looking for a text file in this case. Here it is. And we're looking at 16 megabyte text file, so you know there's a lot of points in it. So here we see we've got X, Y, and Z information in that file. Let's build a surface from this. I think this is part of the Columbia River drainage. So name the surface and name the connection. Let's do a coordinate system conversion as well. So we want to convert this into a Washington state plane south zone meter. Let's do that. So we can perform a coordinate system conversion as well. Overwrite the existing file. You can see that I was messing around with this earlier, and I obviously named it Columbia as well. So let's let it overwrite that file. Again, with over 500,000 points, this is going to take just a minute to process all that data. So now we've got the surface. We can look in here, we see our connection. Add that to the map. Take a quick look at the style. Turn the hill shade off for a moment. Kind of took everything away, didn't it? Take a look at this surface. So we can see that we've got a true 3D raster-based surface here. Let's do this. Let's go into 3D with it. And as we've been able to do in other surfaces, we can spin that around, get a good look at it. We see the heel shade is on, so we get a nice look at that. We can do some other things with the style of this here. We can theme. Let's build a theme that is themed based on the slope with an equal distribution. Let's go with a palette here. I think we've got a slope palette. We do have a slope palette. Let's use that to theme. Take a look at our band details. So here are our details for our different slope ranges and the colors we would expect to see. Shade off for a moment. So there's some some slope coloring for that surface based on the information that we built from LiDAR. Turn the hill shade back on and you get even a little better perspective as to what's going on, so you can really see the shading there in the steep parts of this slope. So that is what the Survey Toolkit brings to Map 3D. The ability to work with point data, whether it be in ASCII format or database format. It gives you the ability to create surfaces from many sources of data and then export those surfaces. So I'm going to go ahead and open the phone lines now so that we can have some discussion, and hopefully you guys have some questions we can discuss regarding the Survey Toolkits. Questions? Uh-huh.